In this video, we're going to discuss direct and inverse variation. This applies to both the math portion of the ACT and the science portion of the ACT. For the math portion, of course, you will be doing you might have calculations that involve direct and inverse variation, but then the science portion, it's good to understand some laws in science that follow these principles. So let me give you a quick example of variation. Now, in our book, the Tyler Wallace algebra book, again, this free resource in our portal, you can find it online as well just by typing Tyler Wallace algebra. If you go to 1.7, it talks about variation, direct and inverse variation. And this is an application of linear equations. When we talk about direct variation or direct proportionality, think about it this way. When you increase one thing, there's an increase in another aspect of it. So if there's an increase in A, there's an increase in B. Or if there's a decrease in A, there's a decrease in B. Think of it as, for example, the bigger the diameter of a circle, the larger its circumference, right? So as the diameter goes up, the circumference goes up. This is a very classic example of direct variation. There are many examples of this, and one example someone could give you is ask, for example, if C varies directly as A, you might have seen this symbol here, variation. So if C varies directly as A, we would say C varies directly as A. That means C is equal to K times A. So you can change a variation to an equation by introducing a constant of variation. And that's what I did in this problem. Then sometimes you can be asked to solve for this constant, which you just divide both sides by A. So that's one aspect of this problem, is knowing how to find a constant of variation. If I say in variation, so if you have a situation of an inverse variation scenario, someone could say, what happens if I say W varies inversely as K? That's an example there. That means that you put one over the other thing, right? Think about an example of inverse relationships. The more people you have at a facility, if you're trying to build a house, the more people you have on the ground, the less the number of days it will take. Now, again, this is assuming that all the people have work to do. So if you have 5 people, for example, and it takes 25 months to build a big facility, if you have 10 people, we would expect that this number will go down, all things being equal, right? So there's an inverse relationship. So with inverse variation, we have here a difference here. If this was direct, you would do like that. So that's direct, and this is inverse. Now, you can solve for the constant of proportionality here by you change this to an equal sign. So W is equal to, but the moment you do that, you have to then you can introduce the letter that you want to use as your constant of constant of variation. So this is just a review video. There is a longer video that you can watch here in our course, but remember that there is the inverse relationship and a direct relationship. A classic example of a problem would say T varies directly. Well, actually, let me give you a different one. So if I say T varies directly as the square of U. So T varies directly as the square of U. Do you see? I said T varies directly as the square of U. So T is equal to K times U squared. And then they tell us to find, so for example, they say if T is 6 and U is 3, right? Solve for K. So you plug in 6 is equal to K times 3 squared. So that becomes 6 is equal to 9 times K. So K is equal, so 6 over 9 or 2 over 3 would be your value for K. In some cases, they can ask you then, for example, you've just solved for K, right? It was 2 over 3. And they could tell you, well, what is the value, right? They could say, what is the value of, so what is the value of, let's see, U when T is equal to, and they could say, for example, equal to 12. So they've given you a new value for T now. You know what K is, and basically you just have to solve for U back in our equation that we've created. So this is an example getting you to think about variation, and you can see this back in 1.7 in the Tyler Wallace book. This is the same principle you would use for inverse variation. So please, if you have questions on inverse or direct variation, do not hesitate to reach out. Let's switch over to the science perspective of it, because this is very important. So in the science perspective, I want to talk quickly about 2 laws. Charles' law, and Boyle's law. Now, the important thing to keep in mind about this is that with the practice for science on the ACT, you just have to basically be familiar with, make sure you're familiar with charts, with graphs, with relationships in the data, right? Relationships in the data. So when you look at data, right, on a table, what is the relationship between the values of the things on the left and the things on the right that are being described, for example? That is something that is very important with the science section. So let's look at Boyle's law first. So now we're bringing practical application to variation. Boyle's law states that if the pressure of a gas, or the pressure, is inversely proportional to the volume, and temperature is when temperature is constant. The pressure is inversely proportional to the volume. And you can visualize this. If you have a container and this is one of the pictures we use in chemistry, think about this as a tool that can increase pressure here. As you bring it down, the pressure is increasing. That means the volume is decreasing, right? But the pressure is increasing. So there's an inverse relationship between pressure and volume. Now I can change this into P is equal to K over V because I changed that sign of variation into an equal sign. And so I can introduce my constant of variation. This K then is equal to PV. Now you might see why we state P1 times V1 is equal to P2 times V2. That's the formula that is used for Boyle's law. So we've just explained briefly how we derive that formula for Boyle's law. We started by stating that pressure and volume have an inverse relationship, and then we go ahead and explain how we can get our K, and then K is equal to PV, and that is how this relationship is established. That's Boyle's law. Then the other scientist, or the other law we're going to talk about, is Charles' law. Charles' law is different. Charles' law says that there's a direct relationship between the volume and the temperature at constant pressure. So volume varies directly as temperature. That means volume is equal to K times T, which in this case, K would be equal to V over T. That's why in chemistry, you might see this formula used for Charles' law. There is a direct relationship between volume and temperature. So we can see the application between variation as we teach it in mathematics and how it ties to science. Science and math have a unique connection. As a matter of fact, Galileo would say math is the language of science. Math gives science some of the fundamental tools that it has to do what it does. So we've talked about Boyle's law, we've talked about Charles' law, we've tried to combine science portion and the math portion of the ACT with the concept of variation. This is a huge part of the science section of the ACT because you're basically dealing with relationships, right? What are you observing on the table? As an increase of, if they gave you a table of pressure, for example, on volume, with an increase in pressure, right? If we went from 1 atmosphere to 2 to 3, what will happen to the volume? Now, they will give you this information. Don't get me wrong. Most of the science section, you're giving what you need, but it's important to have some sort of idea and understanding of the relationships between the values in a table. What does an increase in one commodity do with the other commodity? Does it increase the other commodity, or does it decrease the other commodity? So put on that mindset of what are the relationships I should pay attention to, and that strategy will help you greatly on the science portion. What is the relationship between the data that I'm giving in my science section? We're going to talk more about this, in the science section. We're going to talk more about the strategies, but I hope that this is something that gets you thinking about that. So keep up the good work, stay tuned, and keep working hard. Have a great day.